কোন দিকে শেয়ার আমি এটা নামিয়েছিলাম, নামানোর পর চলে গেছে।
ক্লিক করতে হবে, তারপরে
শেয়ার করলে কি আসবে?
শেয়ার হয়ে গেছে।
স্ক্রিনটা শেয়ার হবে কি করে?
তবে এটা না উঠালে কিভাবে হবে? কোনটা এটা?
প্রথম নট সো আধা ঘন্টা দেরি হতো, ওরা ঠিক করতো।
Hello. Good afternoon, sir. Good afternoon, Gautam, sir. Good afternoon, Gautam, sir. Sir, we are just waiting for participants to join quickly.
Hello. Good afternoon.
Sir, আর কয়েকজনের জয়েনিং করে দেবে, মাইক্রোফোনটা ইউজ করে ইন্ট্রোডাকশন করার পরে বলবেন।
মাইক্রোফোন মিউট করবো তো? ঠিক আছে।
Okay, so a very good afternoon to one and all. So we start the third session for today, and today we have with us Professor Gautam Saha from the Department of IT, Northeastern University, Shillong, Meghalaya. So before I request sir to commence with his lecture, I would like to give a brief introduction of sir. Professor Gautam Saha received the BE in Electrical Engineering and the ME in ENTC Engineering from Calcutta University in 1984 respectively. He received a PhD degree from the Indian Institute of Technology, Kharagpur in 2000. He has got postdoctoral research experience from IIT Kharagpur and the Ben Gurion University, Israel. He worked with the then Regional Engineering College, Durgapur, India as a lecturer. He worked in EC department of Kalyani Government Engineering College, India. He worked with the Curriculum Development Center, NITTR Kolkata as assistant professor, worked as the associate professor and the head of IT and CSE departments in GCELT Kolkata. Presently is working as the professor and head of IT department, Northeastern Hill University, Shillong, India. He has also served as Dean School of Technology, Nehu, for 3 years. So he has also uh, rendered many administrative responsibilities. He held publications and PhD guidance and MTech thesis guidance and other laurels in his credits along with patents. So with this brief introduction, I request Sir to kindly deliver his invited lecture for all of us. Thank you.
Acha. Me. Can you hear me?
It's audible, sir.
Audible, okay, fine.
I hope I was able to many of you. I introduced Sir, but some participants say that there was some sound issue in hearing me. I had introduced Sir.
You are audible now.
Continue with the talk. Yes, sir.
You are audible now.
Okay, sir. Sir, okay.
I'm now starting, starting my lecture now. So now let me present mine. This thing share, and then this one. Yes. Oh, fine. Can you see the slides?
Yes, sir. It is visible.
It is visible. Okay, fine. So anyway, let me start.
Okay, sir. Sure, sir. Thanks.
Sure. Okay, thank you. So you know, my my introduction has been told to you. This IoT is a very new domain, and so naturally everybody is new in this domain. Now, I am also initially I was working in the area of something different, totally different from this area. In gene regulatory network, it is totally genetic engineering. Now, I have shifted last, I will say last 4 to 5 years, I have shifted my focus from genes to this particular domain. This is a very interesting topic. This is an interesting topic. IoT is a very interesting topic. IoT was, you know, the origin of IoT was WSN, Wireless Sensor Network, and its origin has its origin. You know, every technology has got most of this type of technologies has got the origin is a war. This war means battlefield. Its origin was IoT's origin was Iraq and USA war. And at that time, what these people, these USA people were doing is that they used to put the cameras, they used to put some cameras and disguised as stone chips, and they used to spread them from they used to drop them from the planes over the the strategic battlefield areas. And what happened, you know, and these particular cameras used to take the pictures very nicely because nobody was bothering about the stone chips, and they were nicely taking the pictures, and they were sending it to the control room of the USA battle control zone, that means in the base stations, and very nicely they could know where is the concentration of soldiers, where is the concentration of planes, what is the concentration of battle tanks, and they can come up with their planes, and they used to destroy them very nicely, very effectively. So and they own the battle very nicely. So by using this technology, which is very virgin at that time. Now, after the battle is over, now people thought, why not to use it for some domestic purpose or the purpose, societal purpose? Why not use this technology for societal purpose? Now, actually, this WSN at that time took some, was refined to some extent, and it was taking the shape of, this IoT, of the present day IoT, Internet of Things. Now, what is Internet of Things? Internet of Things is known to you because I think today is the second day probably. Yes, what is Internet thing has been told to you by many speakers. I am also repeating the same thing, but I will not repeat very long sentences. I will repeat it in 2 to 3 sentences. What is Internet of Things? Internet of Things means communication between things to things. So what is the relationship between mobile phone and Internet of Things? Is it clear to you? What is the difference between mobile, as we are talking from person to person, and IoT? What is the difference between these two? See, mobile phone, using the mobile phone, I can speak from here to NIT Shillong. I can speak from here to Bombay, etc., etc. And Internet of Things, what is the difference is that Internet of Things, apart from this, they can, one sensor can talk to another sensor or another actuator, better to say. One sensor can talk to another sensor or actuator, or in particular receiving stations. So this is basically what is called IoT. And that means mobile phone is a subdomain of IoT systems. IoT has got much more spread. Yeah, I'm in a meeting. Huh? I'm in a meeting.
Okay.
So also Internet is a much more wider, has got a very wide scope than the mobile phone. It includes everything. So now Internet of Things was introduced. It was in the research area. A lot of papers were found out on the IoT, and people expected that a lot of Internet of Things will come up into the society. But this has not come up to a level which we expected. It didn't take up its utility was not shoot up to a particular level, to a level which we expected. It was concentrated or focused on the factory premises where they were using, and some specific areas, some very specific areas where it was used. But mostly it remained in the research labs. But it didn't shoot up, it didn't take up the positions due to many factors, because of many limitations of IoT. So in this particular session, I will talk about what are the limitations of IoT for which the IoT applications didn't take its shape as it should have taken. Okay, this is number 1. And next, obviously, if there is a problem, there must be a solution. So what can be the probable solutions with which this particular problems of IoT can be solved? The particular problems or the limitations of the IoT systems which is facing now, it can be solved. So these are the things which I will discuss. And here I'm here working with this particular research areas for last 4 years, and I will tell you my research areas domains also and what we have done. We have also got some patents out of it. We got some papers of the range of IEEE also, and we are expecting to get few more also in future. So this is a very fertile research domain. If you do research on it, and since it is very new, you can get a lot of papers, a lot of good papers, a lot of patents from here. Not only that, if you can use this particular, if you can explore this particular domain, you can have your own startup business also, which is government is giving maximum emphasis on it. You can have your own startup unit and having very low capital investment also. So let me start. IoT architectures, outline of IoT architectures is, so our topic will be moving around these particular domains. I will first discuss about what is the conventional IoT architectures. Next, I will discuss IoT key issues and challenges. What are the issues and challenges of IoT, and how to solve them. So, how to solve this architecture? Let me tell you a bit, just in one-liner, and what is everything all about in this particular my index, what I am showing you. So, IoT has been, the existing conventional IoT has been improved to fog-based IoT to get some advantage, to overcome some limitations of the existing conventional IoT systems. Now, still many problems persist in fog-based IoT systems. So still then we then started thinking, why not to mix this thing, the problems with other technologies? Why not to hybridize IoT with other technologies and see what is the effect of that? This is our research domain, of course. So next will be SDN-based IoT architecture. We have infused SDN technology into IoT architecture, and we are investigating what are the main advantages we are getting from here. Next is we have further improved SDN-based IoT architecture to SDN-based IoT fog architecture. This is better architecture. It gives better performance than the SDN IoT architecture to in some fields or areas. Fog-based Internet of Energy. Energy is a main problem of IoT. So this is also another systems which we have, which has been obtained from the papers. Security is a very, very prominent feature, very, very prominent issues why the IoTs are not being used in many key areas like railways, banks, etc., where it should have been used by this time now. So security is the very, very key area. So to overcome the security issues, we have introduced blockchain concept into IoT. And so for that reason, IoT architecture has to be maneuvered. So we will also discuss about blockchain-based IoT architecture. Then to facilitate further or to make it better architecture for compatible for blockchain, better blockchain compatibility, we have used blockchain-based SDN fog IoT architecture. SDN fog IoT architecture, it gives better compatibility with the blockchain systems. And next is SDN IoT with big data analytics architecture. Now let me tell you one thing. Let me tell you one very important thing is that, one very important thing is that the IoT system having the conventional IoT systems use the devices which are resource constraint and energy constraint. Resource constraint means what? They have got small processor, small memory systems, etc. So its computational power is highly limited, and any very good, better or security systems requires very good computational power. And if you use those resource constant devices for high computational elements requirement, then what will happen? This time consumption will be very high, and so it will be incompatible for real-time work. So for that reason, security for maintaining the security aspects, for providing better security to IoT devices, we have used a special type of architecture, SDN-based fog IoT architecture, which I will discuss definitely in details in this session. And big data analytics, of course. Big data analytics means what? Big data requires a lot of computational power. those who are doing research on big data, they knows it. Even data analytics is also requires a good computational power. Big data takes much more. So if big data analytics has to be maneuvered, that means big data means what? Video images. This is a sort of big data. So if you want to extract information from the videos, so we require some specialized IoT architectures. Those I will also try to touch upon. Though these are all in the research stage, most of these are in research stage, but still I will, whatever we have done, I will share with you. Now, IoT architecture, you see the revolution of IoT architecture A, B, C, D. Last one will be D, sorry. So these are the IoT architectures. These are the 4 IoT architectures. So these are the four IoT architectures, the evolution of IoT architectures. First, you see perception. If you think about the Iraq and USA war, A was used. Perception layer means the sensors, where the cameras disguised in some stone chips were spread along the battlefield. That is the perception layer. Network layer is used for, this is the particular layer which is responsible for sending the data acquired by the sensors to the control room of the USA, where the who are controlling the battlefield. So network layer is the communication layer, and application layer means from there they're analyzing the data, and from there they're taking the decisions what to do. And again, if they take decision, if they want to do some decisions making systems, they has to if they want to do any decisions, then what they have to do, they have to it is possible that from there they can ignite some, they can give command to some rocket systems somewhere which will fire that particular battlefield area. So this is the particular 3 layers architecture of IoT, which is further improved into this B architecture. IoT architecture is B. Coordination layer was there. So backbone layer was there, middleware layer was also there, and application layer also there. So what happened, the backbone layer is basically meant for communication, and coordination layer means what? The data can come from heterogeneous sources. So heterogeneous sources means what? I can send the temperature data in degrees centigrade and in degree Fahrenheit. So if you, for getting information from them, I have to convert them in a single unit, either in Fahrenheit or in degree centigrade. So this is one type of data heterogeneity handling. Another type of heterogeneity may arise, data may come from different network systems, maybe from Zigbee, from 6LoWPAN, etc., etc. For different, having some different communication protocols. So what will happen if it happens like that? Then in that case, that integration, that means to converting all the heterogeneous systems into a single layer, the coordination layer does the middle basic things, and through middle layer it goes to the application layer. The third one is objects, sensors, object abstraction, same thing, almost the same thing they're doing. And service layer means the service management means here comes the big data. That means the huge amount of data which are coming and stored, how it can be stored into that some devices. That particular management is coming over here, and service compositions are over here, and application layers also there. So lastly is object abstraction, service management, application layer, and business layer. Here comes, that means the big corporate houses, which the data are coming from from different sources all over the world, and the application layer data analysis is done, say by using data mining tools. From there, the business layer means they take the decision, the product mix, etc., etc., and in a region wise, and they take the decision from there how to enhance that business using the product mix. So this is the basic conventional IoT architectures, which has been evolved from A to B, B to C, C to D. Okay, so next I am coming to IoT three-tier architecture. IoT three-tier architecture, that is the first architecture. As I have told you, the first layer consists of the perception layer. So in this particular layer, there are sensors are situated. A lot of sensors are there. Different type of sensors are there. Network layer is the communication layer. Routers, etc. are there. Gateways are there. Application layer is basically clouds and servers, where the data from these network layers are stored over there for the what is appropriate applications. Okay, and it is two-way service from the application layer. And the commands, after getting the analysis, after doing the analysis, it can inform some other systems in the perception layer via the network layer. It is possible. So this is the basic and very elementary IoT system architecture, three-tier architecture: perception layer, network layer, and application layer. Next is IoT key issues and challenges. Now, IoT has got these IoT systems, whatever you say, has got some challenges. What are the challenges? Let us see. Challenges are, you see, standardization, network performances in QoS, quality of service, power and energy consumptions, how to reduce that, security and privacy. This is also a key factor which is blocking the IoT's utility. Management and self-configuration. Sensors can be here, there, everywhere. Sensors may grow up, sensors may destroy it. So how to manage these sensors and how efficiently the communication can be connected between can be maintained efficiently. So this is a very great work, management and self configurations in the face of any sensors. So it is basically how there are a lot of sensors in the battlefield, how they talk. You see, you think of the battlefield of the Iran-Iraq war. They were simply throwing the cameras and with some limited amount of battery systems. Now, some of the batteries may die out. Some of the batteries may because their lifetime has got some limitations. So how to efficiently send the data from there to meaningful data from there to the central command. So what they do is that inside there are a lot of sensors which has been spread over the battlefield, and they used to select one base stations among them. The base stations are a bit bigger and having slight mobility. They have got this particular sensors has got slight mobility, others do not have. So what happened when some sensors are dying or something is happening, the communications become problematic. Then these particular sensors which is called the base stations can move to have suitable positions after doing some calculations, so that the communications can be restored and communications can be efficiently done. So this is management and self-configurations. This is also a very great part, because even nowadays in the organized IoT systems, during daytime, lots of cars are moving with so many IoT systems, but at night, the number of cars are limited. So what happens, there will be a peak load and there will be a zero load. So how to manage this particular configuration? So this is an issue. Scalability is also same thing. Scalability means if I design with respect to the peak load, then the things will be idle during night time. So how to make the things more scalable, so that I can get some economic or commercial viability. Data processing, data storage, data processing, and visualization. I already told you that IoT is a very much resource constrained, energy constrained devices. Data storage, data processing, etc. are very difficult in those particular low powered systems. So how to handle these issues? So this is a challenge. And these are still a persistent good research issues nowadays. Availability and reliability. Of course, reliability is a very big issue out there. Reliability is definitely a big issue in IoT systems. Reliability is really a threat to IoT systems in the present time. And interoperability and integrations. Interoperability means, as I've told you, interoperability means I have got different systems which can communicate, which is IoT system has to handle. So some card is coming from, say, China, some card is coming from USA with some different others, with some IoT devices having different protocols or different systems. So how I have to, but our India or Shillong has got something different. So how to interoperability can be very efficiently done in between. So that is also a challenge. So architecture, different architecture, IoT architectures is used in different places. So how these different architectures can be communicated among themselves efficiently. So everything is done by standardization, by efficient standardizations also is required, but that is not there till now. So these are the IoT challenges which are, as I have told you, IT is not getting its proper or appropriate utility till date because of these challenges. Okay, now. So as I have told you, key issues and IT challenges. IT-based systems usually complex due to the tremendous impact on all aspects of human lives, as well as its various technologies deployed to enable autonomous data exchange between the embedded devices, because they are heterogeneous. So autonomous data exchange is a issue. And so development of IT has an impact on various aspects of lives: security, safety, health, mobility. These are environment, sustainability, etc. These are the different development of IoT has impact on the various aspects of human life. So these are the areas where IoT systems can play very nicely. IoT-related issues and challenges need to be considered from various aspects, such as enabling technologies, services, and applications and business models, social and environmental aspects. Most of the open issues arise due to an increased number of connected devices, which causes increased traffic demands. With these are already discussed. Other issues are related to the integration of various technologies and heterogeneous environment, increased data storage, and processing demands on privacy and security risk, etc. Challenges which already had in this particular this particular picture. Now, next is standardization, IT standard improvement. Standardization is diversities. Standardization of IT architecture and communication technology is considered to be backbone of IT development in future. Standardization of IoT architecture is very plays an important role. We are in this particular lecture, we will be focusing on the IoT architecture. So now, open standards are one of the key factors to be successful for the successful deployment of IoT. There are various open standards which just come up. So those we are very much using, and those are so friendly for the research workers in my department. Just I cannot tell you. Otherwise, many researchers could not have been is possible without the open standard things which are available in the net. So they are really very friendly, and they are always used. I will tell you one by one what are the open standards things which you have been using in our in improved architectures. Using open standards, there is an issue. There is less chances of being limited to a specific vendor or technologies, which are very important factors for IT development. So, you know, IoT systems means what? The sensors are developed, but not necessarily by one single manufacturer. It is developed by so many potential customers. Potential, you see, manufacturers. So everybody has got their own standard specifications. So they are totally heterogeneous systems. But standardization in IT system is still not very much prominent nowadays till now. So open standard, if we use any open standard things, that means it will be used by so many people. So they will give you the better standard. That means there are several open standard things which are available in the net, but which the standard which is the best that will be used mostly by the different researchers or different developers. So that standard will get priority, and that standard will be used by most of us, and it will gradually help us in getting the standardization procedures. Next is improved IoT, improvement is, you see, the main standardization bodies are ITU, HC, IETE, IEEE, etc., as you can see, NIST, etc., are involved in the effort to make the framework of IoT standards. They are the bodies which are responsible for IoT standards. Architectures, systems should be framed within open IoT architecture. So systems should be framed within open IoT architecture, a set of standards to enable the integration of various technologies to support full interoperability. IoT systems is saturated, but if we want to mix different technologies with the existing conventional IoT technologies, then interoperability becomes a very key issue. Needs to provide interoperability and full support mobility to ensure service continuity. So that means if we can mix the existing IoT with some other different standards of technologies, then we can develop a better IoT architecture. But when we are mixing up two technologies, there comes this interoperability issues. So this is also a challenge, IoT challenge, which needs to be solved. One of the main challenges with IoT systems is to use an open, integrated, and standardized architecture with separated application of logic and hardware infrastructure. Need to support heterogeneous natures of things. So whatever things we develop, it has to support the heterogeneous nature of things, networks, data, applications to support full interoperability. Key design requirements are scalability, interoperability. Whenever we are developing any architecture, its main focus will be how to enhance the scalability, interoperability, openness, and modularity in a heterogeneous environment. So these are the things, and so that means when you'll be doing that, we have to first do the generalized architecture. Hardware and network architecture has to be developed in that way. Software architecture has to be developed keeping in view of the hardware, and then process architecture has to be developed keeping in view of the all above three. Next is interoperability and integrations. Interoperability issues is considered to be across all the layers in IT systems. The IT systems need to provide interoperability over heterogeneous devices, networks, and a variety of communication protocols. So you see, these are so many protocols are there which are used by the IoT systems: IPv6, IPv4, 6LoWPAN/RPL, WAP or core, Zigbee, GSM, GPRS, Wi-Fi, Bluetooth, RFID, etc. Organizational interoperability is usually associated with ability to data exchange, even though using different information systems and infrastructures. So this is also another interoperability issues that need to be the developed architecture should take care. This is also difficulty which is faced by the existing IoT system. So we are going to develop something which can handle these things very efficiently. Improvements is technical interoperability, integration of different subsystems regardless of their native communication protocols. HATNet, heterogeneous networking paradigm that supports the different MAC and physical layers. Gateways provide several solutions such as protocol conversions, centralized and remote connectivity depending on the purpose and layers where they are implemented. API-based solutions are also there for interoperability, for interoperability that can be used for the automatic conversions between the various application protocols. Some operating systems like Contaki, note it. These are the very important things if you do research on it. Some operating systems like Contaki, RIoT OS, Android, TinyOS, LightOS, etc. enable modular design and provide open APIs which are necessary for application interoperability. Syntactical interoperability is associated with understanding of content and refers to data formats, syntaxes, and coding such as XML and HTML. Semantic interoperability enables interpretation of content and to be shared by communication parties and IoT hardware software platforms. So next is availability and reliability. The availability of the services is one of the key issues to be addressed to properly be managed by dynamics of IoT systems. Availability means the IoT application should be available anywhere, anytime for every authorized object. Okay, for every authorized object. The object hat are going to connect objects hat are going to be connected should be adaptive and intelligent to support seamless connectivity and desired connectivity. Availability of network and its convergence must enable the continuity of services use regardless of mobility, dynamic changes of network topology, and current use of technologies. You understand this? Availability of the network. That means, see, IoT systems means what? A car is moving with many IoT devices. That means it is a mobile devices. Availability of the network and its coverage must enable the continuity of services regardless of the mobility, dynamic change of network topology, or the current use of technologies, or the currently the used technologies. So under these conditions, so reliability should be maintained. The communication should be seamless. Okay, so these are the technologies which are used nowadays for the purpose. Next, data storage and processing and visualizations with a huge increase of connected objects and data traffic volume. There requires a requirement of new calibration and analytic techniques. It's a common analytic platform to support big data, which need to be delivered as a service to IoT applications. Various data mining methods such as AI, artificial intelligence, machine learning, and other intelligent decision-making algorithms enable our computational processes to discover the pattern in large data sets. In this particular session, as I have seen the routine, and that a lot of AI emphasis on IoT will be discussed with you, and how they can be implemented efficiently. What are the suitable architecture that I will discuss in due course in this lecture. So improvements these are the improvements as we have seen. Next is scalability. Scalability means ability to add new devices and services to the IoT systems without degrading the existing service performance. So this is a challenge. Scalability is a challenge to existing IoT systems. Ability to add new devices and services to the IoT systems without degrading the existing service performances. IoT systems must be opened for addition of sensor nodes and deletion of sensor nodes. Okay, so under any condition, the communication should be seamless. Support of a large number of various devices with memory, processing, and bandwidth and other resource constraints. Support a large number of various devices with memory and processing and bandwidth and other resource constraints. Okay. The scalable mechanisms must be deployed for different discovery of devices. Scalable mechanism must be deployed. Okay. To enable the scalability, there must be used a layered framework and architecture. Design of IoT architecture that support the scalability is a big challenge. That it comes to the future development of the IoT systems. So improvement, the cloud-based platform is used. Cloud of things are the one of the technology can be used for the global architecture to scale up the cloud computing, edge computing systems that extends the cloud services to the edge devices. These particular systems we have worked a lot. Edge computing systems, CCN visions with the next generation of network architecture enables the automatic and application neutral catching in memory where it should be located in the network. Next is management and self-configuration. IoT devices must be enabled to identify the various smart objects and interact with them to provide efficient management and self-organization functionalities. Like this I have already discussed earlier. IoT systems has the capability of dynamic adoption of changes in its environment. I have also told it. Topology management. IoT's topology is very much dynamic. device synchronization, as well as traffic and congestion control management. Sometimes what will happen in Shillong during office time, the Police Bazaar area will be highly congested. So, but the other areas will be less. But during night time, that particular area will be totally vacant because there are less number of domestic houses over there. So, devices synchronization as well as traffic and congestion control is also a very big issue in existing IT systems. Management of self configurations, I have already told about you. Network performance and QoS, quality of service. The traffic loads and various traffic models which have dramatic impact on the network performance and QoS. As I have told you, traffic loads and various traffic models which have dramatic impact on the network's performance. Network performance, obviously it will be disturbed if all of a sudden a particular area becomes highly loaded and other areas becomes drastically much less loaded. So it will be a challenge to any network systems to handle. And if the load varies with respect to time, that is also a challenge. The issues related to QoS includes bandwidth, throughput, and latency. So QoS here will be discussed. QoS will mean the specification of the QoS means quality of service. We mean bandwidth requirement, throughput means how many computations, etc., operations are performed per unit time. Latency means for going and coming, how much time is required, etc. Routing protocols affect reliability and other performance of IT systems. Routing protocols also affect reliability and other performance of the IT systems. So routing protocols has to be has a great effect on or routing protocols augment the performance of a developed architecture, IoT architecture. Now, power and energy consumptions. The power and IoT devices, as I have told you, is very low power system. It has got limited battery systems. It is generally powered by battery. So battery has got finite amount of time. So lifetime. So how to efficiently or optimally use these batteries so that its lifetime, so that the things becomes much more reliable. It is another research issue. This is a power, power and energy consumption. Optimization of power and energy consumption in IoT devices is also another research issues. Okay, integrated large compositions with small embedded devices that have low power consumptions. That means if you want to do huge computations in a small device, it will generally require a good amount of power. So what I have to do, I have to go for distributed computation, so that everybody has got limited amount of computation, so that battery can be saved. Improving the device's capabilities while reducing the both cost and device and power consumption. In improving the device's capabilities while reducing both cost of the devices and power consumption. So this is also another challenge. Okay, so these to overcome these challenges. So security and privacy, as I have told you, security and privacy is a great challenge for which ITs can be used by railways, I cannot be used by banks, etc. And why the security is a challenge? Because it's lesser computational power and limited amount of energy or power, limited energy constraint, or its energy constraints. So we have to think of something how to provide this security and privacy in the nicely can be provided inside the IoT systems using some suitable architectures. Okay, now come here. Now what I have told you is it becomes a boring, I think. Boring, what I mean to say that I have told you what are the difficulties, how they are solved, etc., etc. Now you see, the existing IoT systems, conventional IoT systems, which I have shown you earlier, the first one, and that particular systems has been with how to improve its performance, to improve its limitations. This particular architecture was first developed, fog-based IoT architecture. What is this fog-based architectures? So you have incorporated, you see, the fog nodes. fog nodes consisting of the routers, different routers, computational, one computers, etc., etc. And the sensors is to talk to the fog nodes. The gateways are also there. That means there are several communication devices in a particular fog. See here, in a particular fog. So when the sensors are delivering data to them, instead of one or two communication devices, you have got a cluster of, you have got a good number of communicating devices. So load is distributed and their performance becomes better. So through these fog nodes, through internet, they are sent to the cloud systems, and from in the cloud, cloud means it's basically everybody knows what is cloud. I'm not explaining what is cloud over here. So in this particular cloud systems, data can be stored, data can be analyzed, and the informations can routed back through the fog node to the destination devices. So this is a fog-based IoT architecture where, using the fog systems, we are overcoming some of the limitations of like scalability issues, etc., etc. Scalability, yeah, basically is an availability issues over this particular existing architecture systems. Now, this fog-based IoT architecture was but you see the hardware requirements becomes here much more increased. Fog means I have to incorporate many communication routers, etc., in a particular fog. So, and engineers means what? Engineers means I will make the things less costly, but it will give me more work. I can get better services from it, but it doesn't satisfy that. So this is definitely a research, very good research output, but its utility was restricted. Next, what we have done is that, so since IoT cannot be improved by the existing architecture, so what we have done to overcome those limitations, as I have told you earlier, so we have used SDN. We have thought of why not to use SDN architecture into these IoT system. Now let us SDN software-defined network. Architecture is this. SDN 3-tier architecture is looks like this. Application layer is on the top. Control layer, some special thing is here which is not there in IoT systems, and infrastructure layer is the bottom layer. Infrastructure layer, the network devices and router switches and access points. This is a dumb layer. This is basically dumb. It's not, no intelligence is there. So what we do is that in the control layer, there are several controllers, or not a several controller. There is a centralized controller system over here. Centralized controller is much more powerful. It's like a laptop or that type of thing. So since the infrastructure layer, here the things are dumb. So every routing, flow rules, etc., everything are controlled from the control layer. Since control layer is a bit bigger, having higher resources and higher energy, definitely a laptop has got much more better energy resources than the sensors, so, or gateways. So they are a bit powerful systems. So if this is a SDN is a system which is I think if these things can be incorporated into IoT, then IoT systems can perform better, and many of the difficulties of the IoT systems due to its resource constraint natures devices can be overcome. Now, so why not to convert SDN based systems into SDN based IoT systems? So we are trying to, here onward, for develop an improved IoT architecture, we will try to amalgamate SDN into IoT systems. So first try is this. Look here. This is an SDN based IoT architecture. Now, think of engineering point of view. If you go to a factory who are using the conventional IoT systems, and if you tell them sir, please throw it out your existing systems. You just install new. I am giving you a very good idea. And this is my research output. SDN is the research output. You use it and you will get better result. Nobody is going to touch your things. Nobody is going to experiment on their systems, your ideas. So, but if you tell them that, sir, let your systems be there as it is, I'll be simply installing some new devices, 1 or 2, and I will improve your system. Then what will happen? Everybody will be interested in purchasing your systems. So here we have done one particular improvement, I will say, in IoT architecture by let the IoT systems be there as it is, and I will incorporate the SDM systems just in between. I will just introduce the system as it is. Look here, smart devices are here. Smart devices are here. Okay, IoT gateways are there. They are part of IoT systems. Look here, the application layer, that means cloud is also there. So smart gateway, then these routers, and then IoT gateways, and the cloud system is the conventional IoT systems, which the factory had got. What I have done, I have just incorporated one SDN systems. Means SDN means I have incorporated SDN means what? This controller, and along with the controller there are some switches. And there are some switches, open flow switches over here. There are some open flow switches over here. So what will happen? What we are doing is that from the IoT gateway is connected to open flow switches. Open flow switches communicate with the controller, and then it comes to the internet through the cloud systems. Only one person. So what is happening is that you see the communication due to the introduction of a controller. This controller does what? This is basically responsible for the routing management. Since it is a very high-end device, they can do better routing management over here. They can do much better routing management than the gateway itself. So we have experimented here. We have experimented this thing in simulation. We have experimented these things in our experimental table, and we have found that systems found to be very much interesting. We have found to be the systems. We have found to be the systems is working the system is working very nicely. The RTP has improved. RTP has considerably improved, and
So,
has improved.
so what is the simulation tool that you have used for?
Mininet. Mininet.
Okay, sir. Thank you, sir.
Just a minute. And our throughput has drastically improved, and our so, and this is so these whole systems has improved our IT performance, QS, to a great extent. Now you see, as I told you, that to just tell the person, to tell the on business point of view, commercial point of view, we have not shifted the gateways. But I don't require at all gateway. OpenFlow switch can do that. OpenFlow switch can perform the same operations as that of the gateways. Now, in the next architecture, you see what we have done. We have removed. We have further organized it. Location one OpenFlow. One is a set of OpenFlow switches. OpenFlow switches gateway has been removed. SDN controller. Okay. Then is connected through core network. See here what has happened. Location one means Shillong. Sensors, lot of sensors which are dynamically connected. Maybe, may not be, but here I am showing it as they are all static. Location 2, all statics at Guwahati. They are connected to OpenFlow switch systems, and the OpenFlow switch through the core network. The core network means what? They are also OpenFlow switches connected in some configuration, topological configurations, and to the controller, And there, as I told you, SDN controller is nothing but it maintains a flow rule. Okay. Other than it maintains a flow rule, and it sends the flow rule to the OpenFlow switch for the further configurations. If there is a communication between within the particular locations, then OpenFlow switch can manage that. If there is if it fails to do, if some new item has come, then what will happen? It will call the SDN controller for helping it with the flow rules, so that the communications can be provided efficiently. So this is how a communication can be achieved. And the SDN controller, it can, and through this, data can be stored in the cloud, and from the cloud will do its own operation, data analysis, data storage, and all these things. And even it is possible from the cloud, the corrective measures can be given back from, say, from Shillong. That one communication has to be going to Guwahati. So it has been sent from here, and SDN controller, through the SDN controller, either it can go through directly to the OpenFlow switch of the Guwahati controller systems to the network in this particular device, or if some data analysis is to be performed, so it can be used from the data storage, huge data storage in the cloud. From the data analytics can be done, and from there the corrective measures can go to the Guwahati devices. So this is SDN based 6-LoWPAN architecture. So it is an improved version. So I have reduced my price over here. Gradually, I am just training my my customer that why you use this gateways, it will take your more energy, it will take your more resources. Let us throw it back, because OpenFlow is sufficient for it. Next architecture is this one. Same thing, but here I used dynamic. Several things together, heterogeneous. Sensor network is there, well as that means vehicular network is there. Okay. And Wi-Fi is also there, Bluetooth is also there, Zigbee is also there. Okay. So through the access point, it has been connected. It has been connected to the OpenFlow switch to the SDN controller, and SDN controller to this particular cloud and cloud systems for its further data storage and data communications between them. And this further analysis from there, and it can go up to the proper appropriation. But one thing I expected one question from you. See here, if I come to the first SDN-based IoT architecture, if this particular controller is gone out of order, what will happen? The whole system will be collapsed. The whole system will collapse. Is not it? I have centralized, if I use a centralized one controller, then the whole system will collapse, definitely. So what we have done also, though I have not shown it over here because this is under patent. So I have used multiple controllers over here, multiple controllers, 3 or 4 controllers have been used over here. So that if a controller is one controller is out of order, the others will take over, and it will work nicely with minimum loss of packets. So that also we have incorporated, and we have performed experimentation, and one paper we have got in WPC over there, and presently we have given it for patenting. Now this I have already told you. Here also same thing. The single SDN controller can be replaced by multiple number of SDN controllers to get what? The get security number, not security, I will say reliability, fault tolerance, better fault tolerance. Because if you rely on a single entity, it's the problem will it will give you much more problem than its advantage, because if it goes out of order, things will collapse, everything will collapse. Next is this I have told you. Similarly, these systems also works very nicely. And simulation, this we have not done on this. We have not done on what is called our. We have not done on experimentation, actual experimentation. We have done it on simulation, and the results was quite good. And here, this is a work. We have got IEEE, one IEEE communication. This IT journal of, that means IEEE journal of IoT. We have got one publication on this particular issue. We also have got one patent over here also. So IoT based, here edge based system, you see, what is the disadvantage of this thing? Look here, everywhere the bandwidth requirement is so high, from the smart devices to the IoT gateway, to the open flow switch, to the SDN controller, to the cloud, and then back. Now, see here also same thing, the bandwidth requirement is very high. Here also the same thing, bandwidth requirement is very high. So we engineers want to gain more profit using preferably less number of equipments, or preferably investing less money. So what we have done, we have given preference on edge computing. What we have done, you see, we have you see the sensors here. Sensors, this blue are the sensors, and the box types, they are open flow switches, and one red is a edge controller. And these particular switches are a special type of switches we have made. We have designed. This is our patent. These can handle different protocols. The 802. IEEE 802.4, 802.11, everything they can handle. Okay. So what happens if there is a controller is inside? So if there is a intra-network communication, so if in network 1, if a communication has to be performed within the network 1, then we need not go to the cloud at all. We can from here through these open flow switches, we can and this on the master controller is there on the red, and the switches will help us in communication. But if the switches doesn't have the flow rules for the good routing devices, then what will happen? It will ask the red controller to help it, and it will send the devices over there. So this is for intra. So you see, I save some bandwidth in sending it to the global one, to the cloud. Now, if network 1 wants to communicate with network 2, this is not sufficient. This controller is not sufficient. So red controllers, this controller doesn't have the flow rules for the network 2. The network 1 is Shillong, network 2 is Guwahati. So that Shillong one doesn't have any flow, communication routing flow rules for the Guwahati. So what in that case, if this controller fails to solve the problem, then what will do to the Buckles network? It will go to the global controller, which is situated in the cloud. And from the cloud, the cloud has got overall view of all the networks. So it will design it, it will route it to the appropriate network, and to the Buckles network, it will come to the destination network. So that means what? For inter-network communication, we are consuming high amount of bandwidth. For intra, the bandwidth requirement is very less. Number 2, its throughput has increased to a great extent, because communication doesn't have to communicate very far away. Its throughput has increased, RTT has considerably latency decreased. So its performance was fantastic, marvelous, and packet loss also hugely decreased. So we got very good result out of this particular network systems. So and so this we have tried to, this we are now trying to implement. With this we are now trying to implement in railway systems. In railway systems means what? Okay, I will come later on. Applications I will come to later on. Just now you see what are the developed architectures. Then I will discuss about where we can use where, so that we can start a good business. Now you see the fog-based IoE architecture network. This is a paper. This is not our work. This we have got it some paper. It is the same thing as I have told you. The same thing, just given in a technically relevant terminology and everything. Okay, So this is the same thing, nothing cloud, nothing more into it. Next is blockchain-based IoT network. See, blockchain-based IoT. Now, how this blockchain-based IoT network struck our head is like this. We wanted to IoTize railways, railway lines, etc. So that the railway accident occurs mostly due to the failure of the railway tracks, sabotage on the railway tracks, parting of the train also causes accidents, and all these things happens. Now, very good. I can use sensors across the railway lines. Fantastic. Okay, they will definitely use for navigation. Excellent navigation they can provide. They can also be used for whether the railway tracks, the health of the health of the tracks, they can monitor. How? Because when the railway engine is going over the line, then what will happen? There will be a sound, and if the railway line is intact, the sound will be something different. And if there is a crack in a railway line developed inside, or weakness in a railway line developed, the sound will be totally different. So how we'll understand it? We'll be getting the sound. We'll do the Fourier transform, and the Fourier transform we will analyze the frequencies available in normal track and available in cracked track. And if we found any existence of those frequencies in some portion of the track, definitely we will let everybody know that a crack is going to happen on this particular portion of the railway line. Please come and replace it. A railway will be so happy to replace it. So, this we have thought of to do it. Railway parting is also same thing. Parting, and also routing, railway routing. One track is coming and another train is also coming. If they come on the same line, the routing, the driver in the driver's cab, one particular monitor will be there where they can see what are the trains and through which track, which trains are coming and going, etc., etc. in at least within 50 kilometers distance apart. So this is very nice. Sounds very nice. Now, I am a criminal. Now, what will happen? What is the problem? I am a criminal. So what I have done, I have put some enemy node somewhere. Some nodes which is giving you misleading information. A train is coming on the same track, but it is showing that it is coming on the different track. I am misleading the driver. So what will happen? There will be an accident. There will be far dangerous consequences of that. Okay, so security is a very big issue. Security is a very big issue. Now, how to provide security for them? Because security is existing IoT. I have told you, gateway is a very small devices, very small, limited resource devices. It cannot do the computations requirement for the requirement to provide the security to its best. Of course, we have also thought of another technology, another things, that a railway engine, when it is moving, some sensors will be put to some different parts of the engine, and its temperature, pressure, etc., will be monitored, and that will be sent through the nodes to the railway to the railway junction stations, and where the engineers will be stationed in the control room to see the condition of the moving engine. If the moving engine's condition, if they appreciate that it's not good, then they will part it up, then they will take it away from that particular junction station. They'll put a new engine over there. So a engine can be repaired when the fault is very little. That means, when a faulty system at its initial stage is repaired, it costs much lesser. So that was also our idea, but our idea was totally cracked by the security issues. So how to solve that issue? So we have thought, why not to use the blockchain here? Now, what is blockchain? Blockchain is nothing but as far as I understand blockchain, I am not very much high-end expert of blockchain, but what I understand as an applicationers of blockchain is that blockchain provides hash function for a block of data, and and it maintains a public ledger. And once I put a generate one hash function for a particular section of data, it is circulated to everybody. So, and so if there is an illegal transaction in particular sections, so its hash function will change, but it will not be the same as it has been communicated or broadcasted to the others. Then everybody will understand some sabotage has been happened over there, and they will cut it out. So that is blockchain. Again, for the blockchain, you require what? You require the SHA-256, SHA-256. This hash function generator systems, and which is time consuming, it takes a lot of time. And so how to, but we cannot provide, our systems are, that systems means our gateway systems cannot handle SHA-256 computational load. So what we have developed this particular architecture. See here, this particular architecture is, you see there are hexagons, several hexagons. These hexagons are different railways. Railway, NF Railway. So NF Railway, Northeast Frontier Railway has got several divisions. So this is Alipurduar division, this is Guwahati division, this is Bongaigaon divisions, like that. There are several divisions. So they are all divisions, and different type of sensors are connected. You see, different types of sensors are connected, and they are they are connected to this. You see, the local blockchain. Everybody is generating. The data has been stored in a particular systems in the Guwahati, in the Maligaon railway. That means the headquarters. They have got a server systems where the blockchain systems will be maintained over there, and it will serve as a public ledger also, and they can find out whether any sensor has been changed or not by an enemy sensor or not, and etc. etc. So this is a systems which we have developed. I will not tell you any further because this is still under construction. I have also a mind to develop a IoT-based railway systems. I have got some business intention also. So what I am telling you for the academic intention is that this is a particular system. You see, the controllers, look here, you have used SDN-based controllers. I have told you what? The controllers are what? Controllers are high powerful laptops. So if the miners are all controllers, these controllers can be used. That means these laptops can be used as a controller and as well as a blockchain maneuvering systems. Then I will have a very good systems over here, and which is manned by very powerful devices. Okay, so this is Guwahati, and so like Guwahati, there will be Eastern Railway in Calcutta, there will be Southern Railway in Madras, and all of them, this type of blocks will be there. Several blocks, or maybe 20 or 30 blocks are there. In railway has got several divisions, and all of them are connected to the railway board through the miners over here, control in the control level. So these miners are connected to the railway board at Delhi. Delhi is sitting with the cloud, because all the data, because railway, lakhs of trains are running, lakhs of data are generated, crores of data are generated. They are all stored in the cloud, and railway board is looking at that particular cloud, and it is not analyze those data in the railway board persons over there, sitting over there. So what they do, they use the data mining tools or the information extraction tool to find out any fault, some dangerous things which is going to happen here or there or not, and they again call back to the different stations through the central local blockchain systems. We have also tested it. We have tested these things by, one type of accident happens due to the driver slips in the train. So we have put a camera in front of the in the driver's train, and so that it can detect the eyelid movement of the driver. If the eyelid movement is becomes slower, that man is asleep. Immediately that report goes to the railway board. Immediately that report comes to this central headquarters, and then to the railway board, and that driver will be punished. And so this is a simple blockchain-based IoT systems which we have done, and till I will do further research on it. Next is Next is, yeah, this is blockchain based SDN fog IoT system. See here, this is not our work. This is a work done in Korea. It is given. Sharma, PK Sharma is from Tezpur University. Chen, Mr. Chen Park JH. This is an IEEE paper. And this is the initial paper through which we got some overview of how blockchain can be implemented in IoT systems very nicely. And we have gone to that level that we have replaced the blockchain, that means SHAS 256 by its lighter variant. Okay, so that the computations can be done very fast. But these particular systems which they have used, they are doing all the blockchain functions in the cloud. Look here, distributed cloud. In the cloud, all the blockchain operations are being performed. Okay, so what happens? These are the sensors. These are all sensor nodes. Okay, these sensor nodes are connected to the fog layer. That means they are communication devices connected in some topology, preferably in mesh. Mesh is the highest secure topology, and from there, all their blockchain operations, the data, etc., their blockchain operations are done from the cloud itself. Okay, so this is, but I don't like cloud because cloud is a system which is used by many people. Though cloud is highly secured, if I say bad about cloud, many people will come and beat me, I know. But still, cloud is handled by many people. I don't believe in cloud 100%. That's why we have used, you see, the miners for the calculation of blockchain. That means arena, so that cloud maneuvering is very little, and our security system increases. So here everything, they have done everything on the cloud systems. Next is so this is the blockchain based IoT fog systems. This is available in the paper, 2017 paper. Next is, you see, SDN IoT with big data analytics. Yes, big data analytics is a great problem. I'm still fighting with it. Big data analysis in IoT system is a problem. So we are using SDN, of course, SDN based IoT system we are using definitely. But you know, SDN means what I have told you is that we have using controller. Controller means nothing but a laptop. Laptop is powerful, but not that powerful to handle the big data so nicely. So what we are doing, we are definitely using distributed computation, but part of the work we are doing in the part of the work, that means a particular work depends on how many steps, pre-processing, etc., heterogeneity removal, then the data analytics, then data visualization. So many steps are there. So some of the steps we will be doing in the SDN controller, and rest of the things we will be doing in the cloud. Okay, so this is how I have thought of how to use the SDN controllers. That means, you see, SDN controllers for the big data analytics. Big data means there are many big Bs. That means data is big. There is a big variety. The heterogeneity is very big. Their data is dynamic. So there are a lot of problems. So whatever data you see here, you see the architecture here. So first, this is the infrastructure layer generating the big data. That means it is taking the picture. Now, think here. We are using the America's cameras in the borders with our neighboring countries. I'm not naming anybody. With our neighboring countries. To what? To maneuver infiltrators. To check infiltration. That means what? We like to see a dog may cross over to country X to India. A cow can come from country X to India. I don't bother. But a man, if a man comes from country X to India, that is a botheration. Okay, so that means there are two parts. One is you have to check video. You have to take the photograph and you have to analyze the photograph, whether it is a man or it is a cow or it is a dog. This is number one. And if it is a man, definitely a signal has to be transmitted back to the BSF station that infiltration occurred. You go and check. Okay. Now, so for those things, what we have done, you see, they are in the infrastructure layer, the cameras will be there. In the network devices, you see, they are used for transmitting the data, video data, through the gateways to the SDN controller. You see, I have used the SDN controllers. Here, the first, they are used for, and number one, the routing, because huge amount of data. And number two is they are doing the pre-processing task, and some amount of 1 or 2 tasks they are doing over here. In the cloud storage, we can use the cloud. We will store the data definitely in the cloud to the limit we have got. And what we will do, we'll just analyze whether it is a dog or cat or not. And then that information will again come back through the SDN controller to the IoT, and so finally to the actuator. That means to our headquarter or to the big data analytics headquarter level, so that we can take care of the whole issue. So this is what is we are. This is what is we are thinking of.
Yeah, we are calling for connecting the plug.
Hello, can you hear me? Can you hear me?
Yes, sir.
Yeah. Okay. Now, sorry, my battery, my laptop was going out of power because we have got power issue over here. Now the power has come. Anyway, I'm very sorry for the interruption. But anyway, this is how we are doing. Is first we are doing semantics, and then we are just removing the heterogeneity of data, and then we are converting into a common type of data, and that is being done by the controller. And then after that, we sending the data to the cloud. But depending on that, depending on the different type of data. So if the data is very sensitive data, so what we will do, we are doing some part of the processing in the controller itself, so that whatever data is going to the cloud, if somebody takes it, somebody accesses it, no information, they will not get any meaningful information from there. So that part we are doing here. Okay, so we definitely will be using Hadoop, and along with that, many other things we'll be using. But if this is a very open area, if I get a good student, definitely we'll do a lot of research work over here. So here my problem is we are not getting very good students here. So anyway, this is a particular SDN-based IoT and big data analytics. This, you see, this can be also be used. This particular architecture can also be used for security purposes, for high-end security purposes, also for bank operations and all these things. They can be used. Of course, for bank systems, we are thinking of implementations of this blockchain systems in the SDN-based IoT. Though these two things, we are still due to lockdown, we are lagging behind. By this time, I thought if the things were correct, we could have advanced into a great extent. But till now, unfortunately, we have not advanced to a great extent. We have done some initial type of works, though we have got papers on it. But still a lot of work needs to be done on this particular area for big data analytics. Big data analytics, I'm telling you, even they have experimented with or performing an operation from London. Operation means surgical operations from London to Italy. The patient was in Italy, doctor is in London, doctor is using a dummy patient and doing the, and just seeing, mimicking and the operations on the table on the dummy patient, and the knife was being exactly handled, maneuvered in the Italy on the patient's body, and the operation was performed very successfully. Though of course there in the Italy there are many doctors are there on that particular site. So this is also possible. This is also possible even in even in conventional IoT using cloud systems. Okay, but we want to do the same thing. But cloud again is definitely have to use cloud, but we will definitely use cloud judiciously so that the cloud is costly. Cloud part is lessened. Cloud part, implication of the cloud part is reduced. So, and we can do more things on the SDN controller. We can do many of the vital things in the SDN controller itself, because I have got a lot of spaces. Apart from it is doing only routing. Apart from routing, there are a lot of backend computational powers are there. Unused computational powers are there, which why not we use them for our purpose? Also, this is all which I'd like to talk, which I like to present to you. My initial phase about talking to the different issues was, I know this is boring, but the later phase was probably not that much boring, because I have shown you how IoT can be improved from existing IoT to fog-based IoT. Then what is SDN controller? How the SDN controller can improve the performance of the IoT and its variant. You see the static variant, dynamic variant, then it's edge computing based variant, then comes energy based variant, and lastly comes the security aspect, the blockchain. This is very, we got a paper also here, but I have got a mind to patent something in this particular aspect, and we're doing work in that direction also, and I've told you my intention. And this is definitely a same thing, which is cloud based, and is a big data analytics in SDN based IoT, not IoT, SDN based IoT. So a lot of work needs to be done over here, definitely. So thank you very much with my limitations.
Thank you very much, sir, for your very good presentation and so much of discussion and illustrations.
Yes, hello.
Questions. So thank you very much for your presentation. Simple.
Yeah.
Now the
Thank
session is open for questions. If there are some quick questions, all participants can ask.
Many of the places we have done the test bed also, test bed operations we have done in most of the places, except the blockchain, and blockchain also we have done, but we have not present. We have we're in the process of publication, and good result, of course. We have done it on the IoT, not on SDN based IoT.
Request participants for any questions.
How many participants are there?
We'll wait for. Yes, sir. Now, right now, 50. Some leaving. So if there is something, then we'll wait for 2-3 minutes.
So is there any? I don't think any question is there.
Yes, sir. We'll just wait for 1-2 minutes. If nothing is there, then we'll officially end the session, sir. Okay, so I think, many things already have been discussed and materials already will be available. So if there are some questions or more like interest points to discuss with the speaker, then the participants may directly contact him also. So officially declare the closing of this session, and let us all thank the speaker. Thank you very much, sir, for your wonderful presentation. Thanks to all the participants for joining us today. Thank you very much. We'll end here.
Thank you.